So this problem is good enough. As far as last problem was concerned, it was a joke. But this problem had some material. It has got some features. So we are going to talk about interaction energy of two dipoles. And what is it? Potential energy of the system. Interaction energies are simply potential energy of the system. So we have two dipoles with dipole moments P1 and P2, which lie on the same plane at a distance r from each other, form angles θ1 and θ2 respectively with some reference. That means with the line connecting the dipoles. Calculate the internal interaction energy of the dipoles. This is a nice question. And this interaction energy is simply the potential energy, and that can be written in form. We have got a formula for this, that is P dot E, dipole moment dot product of so I would like to undo things, and then I would like to write it again, that potential energy simply can be written as minus P dot E. That you must have obtained this formula in your studies, and it determines the energy of a point dipole with the dipole moment P in an external electric field E. And in this case, the external field acting on dipole 1, which one is dipole 1? P1 with P dipole moment vector P1, and this is created by dipole 2. So interaction energy of the dipoles we can write minus P1 dot E2. It's simple. And E2 is what? E2 we know is, we can write, and we have already calculated, it can be written in form of 3P2 P2 dot R, because we are calculating electric field produced by dipole 2, and that is a position vector divided by magnitude of position vector raised to power 5 minus P2 vector by R cube. So this is the electric field produced by the second dipole at the location of the first dipole, and we can expand the scalar product, and or we can perform this potential energy simply as U equals minus P1 E2, and we can place the E2 from here to this place, and I'm going to do it, and it is minus 1 by 4 pi epsilon naught P1 dot, and then E2, from E2 I got it out here safely, and I can write here simply P3 P2 dot R vector divided by R5 minus P2 vector by R cube, and next we are going to get 1 by 4 pi epsilon naught P1 dot P2. That means 3 is here, and I can write here P1 R, P2 dot R here, and P1, and this dot product becomes simply P1 R multiplied by P2 dot R divided by R5, and minus P1 dot P2 by R cube, and I just put P1 from P1 and this R here, so it becomes P1 dot R, and then we have 3 and P2 dot R, and I calculated things, and now I can write minus 1 by 4 pi epsilon naught P1 P2 P1 simply P1 P2 by R cube, and P1 dot R, the angle between P1 and R is theta 1 and P2 and R is theta 2, so I can write it here. If I took out P1 and P2, then I can simply write here 3 cos theta 1 multiplied by cos theta 2, and next P1 dot P2, and the angle between P1 and P2 is what? Angle between P1 and P2 is cos theta 1 minus theta 2, so I can write here simply P1 P2 has been taken out, and this can be written as theta 1 minus theta 2. This becomes cos theta 1 minus theta 2, and surplus R, this is all R cube. Okay, so the result is this. We can calculate this thing by writing E2, and we got this result. You can calculate it yourself. There is no big deal. So this is the interaction energy of the system, and this may be a formula as well. If you want to remember such a long formula, that's your problem, not mine. I can simply say that potential energy and the interaction energy is maximum when I guess when theta 1 and theta 2 both are equal to 90 degree, cos 0, and cos 0 is 1, and then the result we will get that 1 by 4 pi epsilon naught P1 P2 by R cube simply. And if theta 1 is equal to 0 and theta 2 equals pi by 2, what will be the result? You can take it, and in this case I'm guessing that the interaction energy will be minimum in case of theta 1 equals 0 and theta 2 equals pi by 2, and when theta 1 equal to theta 2 equal to pi by 2, the potential interaction energy is going to be maximum, because in this case the potential energy is 1 by 4 pi epsilon naught P2 P1 P2 by R cube, and in this case this comes with a minus sign or something like that. No, it may be incorrect. It may be incorrect in interpretation. I am not interpreting. You can get your maximum and minimum by yourself. And this is the interaction energy. I tried to calculate, and I calculated it. Thank you very much for watching.